This lesson is about right triangles and similar triangles. Because right triangles all have a 90-degree angle, they already have one angle that is congruent. That allows us to use some additional special theorems to prove that angles are congruent. The first one is called the leg-leg theorem, or LL. It says that if the legs of one right triangle are congruent to the corresponding legs of another right triangle, then the triangles are congruent. So essentially I have these two legs are congruent to these two legs. The reason that this works is I already know that this 90-degree angle is congruent among the triangles. So in a right triangle, we call this the leg-leg theorem, but it's really no different than the side-angle-side theorem. Another special one is the hypotenuse angle theorem. This says that if the hypotenuse and an acute angle of one right triangle are congruent to the hypotenuse and the acute angle of another right triangle, then the triangles are congruent. Again, keep in mind that they also have one 90-degree angle in common. So for a right triangle, we give it the special name of hypotenuse angle, but really it's no different than angle, angle, side. The next theorem specific to right triangles is called the leg angle theorem. It says that if one leg and an acute angle of one triangle are congruent to the corresponding leg and acute angle of another right triangle, then the angles are congruent. And remember again that we also know we have our 90-degree angle in each one. So in a right triangle, we call this the leg angle theorem, but it's really no different than the angle-side angle or the angle-angle-side theorems. The last one specific to right triangles is called hypotenuse leg. This one says that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the triangles are congruent. So in a right triangle, we specifically call this the hypotenuse leg theorem. Next, we're going to talk about similar triangles. Similar triangles are triangles that have the same shape, but they're different sizes. So remember that congruent triangles have the same shape, same size. Similar has same shape and different size. We use a ratio, which is a comparison of two numbers using division in order to determine whether or not triangles are actually similar. A proportion says that two ratios are equal. So in using this to solve problems for similar triangles, for example, I have my triangle ABC and my triangle DEF. These two triangles are similar if the ratio of the corresponding sides are equal to the ratio of other corresponding sides. So for example, in this case, I would have to know that 4 was proportional to 8 in the same way that 3 is proportional to 6. And of course, if I do 4 divided by 8, I get 1/2. 3 divided by 6 is 1/2. And 5 divided by 10 is also 1/2. So I'm able to conclude that yes, these triangles actually are proportional, and therefore they are similar triangles. If I don't know the side of one triangle, for example, suppose that in triangle DEF I only knew that side DF was 6, but I knew that triangle ABC was similar, I could set up a proportion such as 3 is to 6 as 4 is to F. I could then cross multiply and solve to discover that F is in fact 8. And I could set up a similar proportion to find side D, in which I would say that 3 is to 6 as 5 is to D, and I would conclude that D is 10. There are several postulates and theorems that we use in order to conclude that triangles are similar. The first one is called angle-angle. Keep in mind that these only apply to similar triangles and not congruent triangles. Angle says that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Keep in mind, if these two angles are the same and these two are the same, and each triangle has an angle sum of 180, then naturally the third angles would also be the same. So again, I've provided an example here if you're interested in how to use a proportion to solve for the side of a triangle, knowing that the two triangles are similar. The next one is called side, 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 and this of course is similar to congruent triangles. But in this case, instead of the sides being equal, they simply have to be proportionate. So we say if the measures of the corresponding sides of two triangles are proportionate, then the triangles are similar. So in this case, I would have to prove, for instance, that side AC is proportionate to PR, that side CB is proportionate to RQ, and that side AB is proportionate to PQ. If all three sides are proportionate, I could conclude that these two triangles are in fact similar. The last one is the side angle side, and this one, a bit lengthier, says if the measure of two sides of a triangle are proportional to the measures of the corresponding sides of another triangle and the included angles are congruent, then the triangles are similar. So in this case, I would have a triangle here in which I have two angles already marked, and it says that these two angles are congruent, and I would check to see if 5 divided by 7.5 is proportional to 4 divided by 6. If I cross multiply and simplify, I get 30 equals 30. So I conclude that yes, if the proportion is true, the triangles are similar. Like congruent triangles, the similarity of triangles is also reflexive, symmetric, and transitive. So I could twist, turn, flip, or slide these triangles across a coordinate plane, and it would not change their similarity.